Hi lads, this video is going to go through the question on page 256 that we're going to be doing in Wednesday's class. So I have it set up there already, and it tells us, given the coordinates of two planes ABC and DEF, to find the line of intersection and the dihedral angle between the planes. So you can see there already it's drawn out, the solution right there, and you can see the two planes intersect. At the moment what we have here is we have our two planes drawn, but we don't have our line of intersection. That's the first thing we need to figure out, is what line is common between the two where the two planes intersect. So this would be similar enough to a previous example we would have looked at. First thing we need to do is we need to find two points that are common between the two planes. In order to do that, we want to cut the plane horizontally. So for example, we could take a cut along E here, and we can see there that when we take a cut along E, it intersects with the line AB at that point there. We'll call it 1. It goes back to the far side along BC at 2 there, and then eventually the horizontal cut hits the line DF at this point here, 3. So somewhere along that line is going to be our line of intersection. So what we need to do is we need to take that into plan then. So we already see E has been taken down, E is there. So I'm going to take down 3 along the line DF first. You can see 3 hits DF at that point there. And I join E to 3. I can see that along the line AB, the horizontal cutting plane hits 1 there. I take that down as well. Hits AB at 1 there, and when it goes through the far side it hits BC at 2. Take that down as well, to BC at 2. So I connect 1 and 2 together as well. And I connect 1 and 2 together, they cross over. You can see 1 to 2, and I extend it out, it hits E3, and that's one end of a line along our line of intersection. So it's 1 point at the end of it. I need to take a second line now, a second horizontal cut, to find another point, because when I have 2 points I can draw a line and that'll give me my line of intersection. So the most common one there I can take is across from C. I already have C as a point. I'll just take a horizontal line across there. You can take a horizontal cut along anywhere. I've just picked 2 points I already have, so E and C, they're the most common ones there. So C goes across, horizontal cutting plane hits off DF along this point here. I can call that 4. It goes through the far side at DE, that point 5, and then hits AB at 6. So I already have C in my plan. I'll take 6 down to hit the line AB. And it hits it at that point there. Happens to be on the same line as E there. And I can join that back now to C. So C to 6 in my plan. And now I need to get point 5, which is along the line ED. There it is there. And then 4 lies along DF. That point there. So I can join 4 to 5. Extend it on through, and you can see it interacts with the line 1, 2, 3 there at this point. Sorry, it should be hitting off. 4 to 5 should be joined through to hit along the line C6, because they're the common line between them. It intersects at that point there. So what I need to do next is join the 2 endpoints that I've found. So where they crossed over initially for 1, 2, 3 and E, that was where the crossover occurred there. I can label that as S. And then along C, 4, 5, 6, they all cross over at this point here. I'll just call that T. So I join S and T together. I get the line of intersection between the 2 planes. So along that line is going to be our line of intersection. So you can see it crosses over along DE. It enters through here. And then at the end of ABC, it stops at that point there. So that's my line of intersection in plan. What I need to now do is draw my my laminar surfaces in heavy then the rest of the way. So I'll be able to see all of this as my outline here. So A connects to C, it'll stop at that point there, and it'll go out through the far side there, and C will go underneath to that point there. E connects to F, and we can see all of that plane there, across to D, and then D will connect to E. It'll be visible to that point, it'll then be dashed underneath, or just hidden, and connect through to there. And that'll be our plan view. Whatever we do in our plan, we take it up to our elevation. So you can see along BC there, that's where the point occurs, or the line of intersection. Take it up, it's BC there. The opposite end of it, along the line ED, take it up, to ED there. Once again, connect those two together for your line of intersection. And we draw in what's heavy then, what we can see in front. Our last line should be there to there. And that's our elevation and plan drawn with our line of intersection. So we just used horizontal cuts. So basically just general cutting planes that give us points along it, and we label them as we go along, because as we label in the elevation, we can take our points down plan and make sure we connect the right lines together. Because as you can see, there's a lot of lines so far drawn. So by labeling, it helps reduce the error then as a result. After that then, the question is fairly straightforward. We need to find the dihedral angle that occurs between the planes. We have our line of intersection. We can see clearly that neither of these lines are parallel to the XY line, so neither of these views have a true length. So the first thing I'm going to do is, from my plan, I'm going to look in perpendicular to my line of intersection. There's my line of intersection there. And I'm going to take up that first to get my true length. I'll just take my X1, Y1 as close as I can to this view here to save me going off the page. So let's take an X1, Y1 across there. What I need to do now is just extend up all my points then. So all my corners then after that. So I already have my two ends of my line of intersection. Now I take up F there. There's corner C. Going across, I have D there. B. And moving down a bit, I can then get corners E and A. So as always, for an auxiliary view, we always go 2 views back when we take our measurements. So 1 view back into my plan, 2 views back into my elevation. So measuring from my XY line up. So A is that height there, follow it down, follow it up, and there I have point A. B is this height here, follow it down, follow it up. This moves up so you can see the top of the question. There's B. C is this height here, follow it down, follow it up, so you can see what's important to label. D is this height here, follow it down and follow it up. And then we have E and F, and then we'll do our line of intersection after that. So the height of E there, follow it down, follow it up. There's E, and then finally F. F is this point over here. Take the height, follow it down, follow it up. And it just about stays on the page there. Just for now, I'll join all these together. So I have my triangle ABC, and then I have my triangle DE and F. My line of intersection. Take my height here for that point, follow it down and follow it up. It curves there, and then my second point is at this height here, follow it down and follow it up. I can join these two together then as well. And then just complete the outline of it afterwards. And I can say there, that's my TL, or my true length of my line of intersection. There we can see where the two planes intersect with each other and our true length. Next we need to do is look perpendicular to our true length. So you can imagine the pencil being the true length there of the line of intersection. By looking perpendicular to that, I'm going to see the pencil as a point, and that means I'll be able to see where the two planes are at an angle then, so we can see the true angle between them. So I need to look in perpendicular to the true length. So I'm going to take an auxiliary view out this way here, and take out all my points there. And then my last point should be B there. Make sure to draw my x2, y2 perpendicular. And I'll just have it just there. Once again, we make sure to go 2 views back every time. So 1 view back into the first auxiliary, 2 views back into my plan. Now you can see the distances here. There's a great distance between the x1, y1 back to, for example, point E there and back to C. So what you can do is you can draw a measure line. And we talked about the measure line before. It's basically a line parallel to the x1, y1, or whatever auxiliary line you're drawing or measuring back from. So I could take that, for example, right back to touch corner D. What I'll do is I'll measure from this line instead. It'll take a shorter distance, but it'll give me the same result because this line here is parallel to my x1, y1. So D, take it up, follow it out. D is actually on the x2, y2 because it's touching off the corner. F, I'll take that one next. Follow it up, follow it out. I have to extend my line out a bit further for this one here. There's F, and then the last corner on that triangle is E. So I need to stretch my compass out to that distance there. Follow it up, and follow it out. There, see there. And they should line up all together as one continuous line. You can see there they do, showing that D and F are all on the one line. It should be the same then for A, B and C. So A is this distance here, follow it up and follow it out. There's corner A. B is this short distance here, follow it up and follow it out. There's B there, and then C. C is up this point here, so I take that distance there, follow it up, and I follow it out. I should be on this line. And there's C. And same again, C, A, B should all line up on one continuous line. And there we have then our dihedral angle in between the two planes. As always, you never know, you might be asked to measure it. What I can do is extend that out and just get my protractor and physically measure the angle. So, you can see there that my angle is about 71 degrees. So if I was ever asked to indicate it, I can show there to the examiner it's 71 degrees. And that completes that question there.